right, welcome back. So when we left, we had found the zeros, which are right here on our table, -1, 0, and 5, 0, and we had found our vertex, 2, 9. This is all review from last time. What we're adding in now is how to flesh this out in a different way. We've already got our zeros and we've got our vertex so that this doesn't look like such a V shape. So what I want is a number to the left of -1. So if I go one space to the left of -1, that's -2. So I'm going to substitute in -2. You want to be careful about your substitution. There's a negative in front of the x, then the x is -2, and then we're squaring it, plus 4 times -2 plus 5. So that becomes -2 squared, which is 4, but then there's a negative on the front, plus 4 times -2, which is -8. Plus 5, and so our y value becomes -7 because -4 plus 8 is -12, and -12 plus 5 is -7. So if we go over to -2 and down to -7, we can put a dot right there. And then I'm going to use my line of symmetry to fill in the other side. This is 1, 2, 3, 4 spaces from the line of symmetry. So it must be 1, 2, 3, 4 spaces from the line of symmetry on the other side. So there is our other dot. And that is at the point 6, -7. Notice because it's symmetrical, they're both -7. And then that's a spot I don't have to calculate. Then let's see, I want a number in between 2 and -1. So I could either use 0 or 1. I'm going to use 0 because that's easy for me to calculate. So it becomes -0 squared plus 4 times 0 plus 5. Well, -0 squared is 0. 4 times 0 is 0. So that's going to leave me with 5. So over to 0 and up to 5 is a dot right there. And then I'm going to use symmetry to get a point on the other side. That's 2 spaces away from the line there. So it's 2 spaces away from the line there. So we fill that in. And as you can see, it makes a much nicer curve shape. If I was better at drawing, it would be better. And so on this one, it should become 0, 5 because of symmetry. Now we can see if this is filled in all automatically, the curve looks much nicer, much less like a V shape and more like the parabola that we're looking for. All right, we want to talk to you today about Desmos, which is your option for an alternative math assignment today instead of doing the Google form. You're going to go to desmos.com and you're going to click Start Graphing, and it's going to pop up looking like this thing on the right-hand side here. And then here's some questions that I want you to go through. I want you to start by graphing y equals x squared. That's the most basic form of any quadratic equation. And then I want you to go through the rest of these questions. Take some notes on those. What happens if the coefficient on x is negative? What happens if you add or subtract from x squared? What happens if you add or subtract from the x? What happens if the coefficient on x is a fraction? Try some of those combinations. You are not required to use Desmos this time on your IP. It is an option for you to use, but next time you will be required to use it. So you might want to do some playing around with it today. On Desmos, I want you to graph the following: a parabola with zeros at -2, 0, and 3, 0, a parabola with vertex at 1, -3, and a parabola that opens down. See if you can make that work. Today you have some choices. You can go to Haiku and find the directions for the parabola in the wild assignment. You can complete this, or you can do the regular IP form. So everybody is doing number 1. As always, you've already watched both parts of the videos, I'm sure. Good job, good job. Then everyone needs to click here, but some of you are going to fill out this whole form. Some of you are going to instead do number 3 and submit it using the Google form. If you have any questions or you're confused about that, email me. You don't have to do both. It is an either or situation. You can choose. All right, good job today. Good to see all of you. Hope to see you soon in office hours. Bye.